Here I'm just going to be looking at electron configuration. You'll need a periodic table to follow along, but if you don't have one, handy, you can simply just go to Google and get a picture of one. I do have one beside me right now. Obviously, as a chemist, you're not required to recall the periodic table, but it's very handy. So there are two ways that I'm going to show you today how you can display the electron configuration of atoms, and I'll be making a separate video on how to show the electron configuration of ions, it's quite simple. It's just less or more electrons depending on positive or negative ions, but yeah, we'll get to that in a sec. So actually there's three ways. I'm going to show you through boxes, then I'm going to show you through obviously just writing down the orbitals that are occupied, the 1s, the 2s, the 2p, 3s, so forth, and then also shorthand electron configuration. So let's consider the element oxygen. Let's consider the element oxygen. Now, oxygen has 8 electrons, obviously, and so it has 2 outer shells. So we're going to note that its principal quantum number is 2, which, if you remember, that consists of 1s, 2s, and 2p. And I looked at these orbitals. I looked at the sp, d, and f orbitals in the previous video. And if you don't know those yet, I would strongly recommend checking that video out before learning this video. Now, he said that oxygen had 8 electrons. So what I'm going to draw is quite a simple graph here, but it's just one where we have energy going up. I'm not going to draw an x-axis. I guess we could put carbon at the bottom, sure. And I'm going to draw n equals 1 here and n equals 2 here. Now, when drawing this out, you don't have to draw out this graph and complicated stuff. If I ask you for the boxes, say an exam question, then just go ahead and draw the boxes. You don't have to draw energy going up, so forth, whatever. So for n equals 1, we only have one orbital, and that is the 1s. Well, we have subshell, that is the 1s, and I'll go ahead and draw that here. Now for 2, remember we have 2s, then we have 3 orbitals for the 2p subshell, right? So here's our 2s, then we have our 2px, then our 2py, and then our 2pz. And remember that orbitals fill up. Let me just label these 1s, 2s, and oh, this was poorly thought about, wasn't it? This obviously has a higher energy than the 2s. Here we go, 2p. And so the orbitals fill up from lowest energy to highest, one by one. So we can look at it this way. We have 8 electrons for carbon, so that's 1 up spin electron, 1 down spin electron. 1 up spin electron, 1 down spin electron. And so that's 1, 2, 3, 4, 5, 6, 7, 8. And I think I remember recalling in the last video that I did talk about spins and electrons. If I have not, the basic idea is that within an orbital there must be the electrons must have opposite spins, so one must have a down spin and one must have an up spin, right? And you can see that how I've drawn that right here in the 1s orbital 2s and 2p orbitals, like so forth. And this is all very well, but what if we want to draw it? The standard way of drawing standard electron configuration is as following. We would have 1s, 2s, 2p, and then we would state how many electrons are of the orbital. Note, remember, you can have only 2 in an s subshell, but you can have, but in all of the p orbitals together, we can have up to 6, right? So 2, 2, but how many are actually here? There are 4, so 2p4, right? And oxygen, I mean, look at my periodic table here. Oxygen can also be written with a shorthand electron configuration. This doesn't make it too short, really. With noble gas helium, which has electron configuration 1s2, and then 2s2, 2p4, like so. Right, so whence our largest noble gas configuration can be written as the noble gas, and then the rest of the configuration that does not satisfy a noble gas, you leave as the same. So let's look at nitrogen. Let's look at nitrogen. You know what, we could use the same thing here, because nitrogen is very similar. Well, it's got a similar number of electrons. So let me rub this out. It has 1s. It has 7 electrons. So let me rub these out very quickly. Just break off the box there. And here we have nitrogen. And so we start filling up our opposites. 1 up spin, 1 down spin, 1 up spin, 1 down spin, 1 up spin, 1 up spin, 1 up spin, and that makes 7. That makes 7. Now, this means that as we write out our electron configuration here, 1s, 2s, 2p, we can now fill in these numbers, can't we? 1s2, 2s2, 2p3, 2p3. And as you look along the periodic table, I'm imagining you have one with you, we can see that along period 2, from boron across, as you count along, it's 3 along. Think, oh, okay, but as you should be able to recall from the last video, the periodic table is broken up into blocks. And so from group 3 or group 13 to group 18, we have this P block, right? So it is actually a lot easier working this out by the periodic table rather than through this ridiculous graph thing that you could draw out. But this is quite good in imagining how the electrons fill up each orbital Alright. So let's look at one more here. We won't use the graph. But let's look at boron. Boron electron configuration. And I'll just draw this out here. But you guys try and pause the video here and see if you can do it, because I think you can. It's pretty easy. Nope. Remember, boron has 5 electrons. 5 electrons. And so, remember how many are in the 1s? Well, there's 2. And in the next s, there's another 2. And so, 2 2 is 4. There's only enough for 1 more electron in the p orbital. There's only going to be 1. And so we've done boron electron configuration just very easily. Now, I want to try and give you a harder one about a rule that I did mention in one of the previous videos. This will be the last one, I promise. We're going to look at the electron configuration for titanium. You will definitely need periodic table for this, I'd assume. But titanium has 22 electrons. So I'd first start drawing this out. 1s2, 2s2. How many does the p go up to? It goes up to 6, and then we go back to the 3s. 3s2, 3p6. Now, from 3, we start having d orbitals, and there's the thing about the 4s orbital, right? And it's the fact that the 4s orbital actually is of a lower energy than the 3d. So the 4s is filled before the 3d. But when drawing it out, it is much nicer to draw the 3d before the 4s. Even though this is confusing, this is what chemists do, and 3d, and it's in chronological order, even though 4s is, as a matter of fact, filled for 3d, and so we now have our 1, 2, 3, 4. It makes 10 electrons, 12, 18, 20, and so we know we're going to have 2 in 3d, as follows. So a very simple way to test yourself electron configuration is just go through periodic table, every single element, up to maybe Mercury or something, and just try and test yourself on electron configuration of every element. It may take a while, but definitely a useful skill to learn for chemistry. So hopefully you've enjoyed this video. If you have any things you would like me to cover in this playlist for physical chemistry, then just comment down below. Thank you.